In this lesson, we're going to talk about how to write the chemical formulas of ionic compounds. Now, before we do so, you need to know the charges of certain ions. So let's focus on the elements in group 1, like lithium, sodium, potassium. These elements, they have one valence electron, and so they tend to form +1 charges, or cations with +1 charges. Now, in the second column, you have the group 2 elements, the alkaline earth metals. And these include elements such as calcium, magnesium, and so forth. These elements, they form ions with a 2+ charge. Now, in the middle, you have transition elements, which can have variable charges. So we're not going to focus on those too much. But moving on to group 13, also known as group 3A, you have elements such as aluminum. I'm going to write it over here. And this element has a 3+ charge. And then you have elements like carbon, silicon, germanium, which are found in group 4A. And for ionic compounds, it's rare that you'll see those elements. In group 5A, you have nitrogen and phosphorus. These form negative charges, specifically -3 charges. And then you have elements like oxygen, sulfur, selenium. These are the chalcogens, which form a -2 charge. And finally, you have the halogens, like fluoride, chloride, bromide, and iodide. And these halogens, they form anions with -1 charges. And so make sure you understand how to determine the charges of ions for certain elements used in the periodic table, because that's going to be important. Now let's start with our first example. Let's say if we want to write the chemical formula that corresponds to sodium bromide. How can we do so? The first thing we need to do is list the ions that are involved here. The sodium ion has a +1 charge, and the bromide ion, it's a halogen, it has a -1 charge. So how can we use this information to write the chemical formula of sodium bromide? Now, if the charges are the same in magnitude, even though they're opposite in sign, so like this is +1, this is -1, if the charges are the same, these ions will combine in a 1-to-1 ratio. So you can simply write them together as NaBr. So that's the answer for this example. So anytime the magnitude of the charges are the same, you could just write the elements together. Let me give you another example of that. So let's say if we want to write the chemical formula for calcium sulfide. Now the first thing we're going to do is write the ions. So calcium is an element in group 2, so therefore as an ion it's going to have a 2+ charge. Sulfide is a chalcogen in group 6A, so it's going to have a 2- charge. Now notice that the magnitude of the charges are the same, 2+ and 2-. So you can simply write them in a 1-to-1 ratio. This is going to be CaS, calcium sulfide. That's the answer for this example. Now let's try another similar problem. Aluminum phosphide. So what is the charge on the aluminum cation? Aluminum is found in group 13 or group 3A, so it has a 3+ charge. And the element phosphorus has a -3 charge as an anion. So writing them together, the answer is simply going to be AlP, because they have the same charge magnitude. But now, what if the magnitude of the charges, what if they're different? What if they're not the same? So what do we do in a situation like that? So for instance, let's say if we want to name aluminum chloride. Let's try this example. So we know that aluminum has a 3 plus charge, and chloride is a halogen with a -1 charge. So how do we work with this? Now there's a technique that we could use. We need to swap the charges with the subscripts. So let me show you. So this 3, we're going to write it as a subscript towards the right. And the 1, not including the negative sign, we're going to write it as a subscript to the left. So this is going to be Al1 Cl3. Now there's no point in writing a subscript of a 1. So in this case, we can just omit the 1 and say AlCl3. It turns out that this is the correct chemical formula for aluminum chloride. Now let's make sense of it. So why do we need the 3? The answer is to balance the charges. We have one aluminum ion with a 3 plus charge. So the total positive charge in this compound is +3. To balance that 3 plus charge, we need 3 chloride ions, each with a -1 charge, so that the total of all the negative charges is -3. So these cancel and they add up to 0. And so that's why the chemical formula is AlCl3. It's to neutralize the charges. We need 3 chloride ions to neutralize the 1 aluminum +3 cation. Now let's work on some more examples. The next one we're going to try is sodium oxide. What is the chemical formula that corresponds to this compound? So let's start with sodium. It's Na+. Now what about oxide? So we have the element oxygen, and oxygen is a chalcogen in group 6A, so it's going to have a -2 charge. So using the method that we used before, we're going to swap the charges with subscripts. So it's going to be Na2O1 or simply Na2O. So this is the answer. So this means that we need 2 sodium cations to neutralize the oxide ion. The total of all the positive charges will be +2, and the total of all the negative charges is -2. So that's why we need 2 sodium cations to balance the -2 charge on the oxygen. And so this is the answer, Na2O. Now let's work on this example. Barium phosphate. Feel free to pause the video if you want to work on that problem. Now barium is an alkaline earth metal found in group 2, so it's going to be Ba2+, and phosphate is a polyatomic ion, which is PO4 3-. And the polyatomic ions, you need to commit that to memory. Now I've created a video on YouTube, and you could search it out. Just type in polyatomic ions organic chemistry tutor in the YouTube search bar, and you can get a list of polyatomic ions that you need to know. So make sure to take a look at that. Now using what some call the crisscross method, this is going to be Ba3PO4 times 2. But because we have a polyatomic ion, because we have multiple polyatomic ions rather, we need to enclose the PO4 ion in parentheses. And so that's how you can write the chemical formula for barium phosphate. So anytime you have multiple polyatomic ions, make sure you surround it in parentheses. Now the last case will be one with a transition metal. So let's say if we have iron 3 sulfate. How can we write the chemical formula for this compound? Now it's important to understand that the Roman numeral that you see here tells us the charge on the metal. So iron has a 3+ charge, and sulfate is a polyatomic ion, which you need to know is SO4 2 minus. So with this information, we can swap the charges with the subscripts. So it's going to be Fe2 SO4 3. And that's basically it. So now you know how to write the chemical formula of ionic compounds. Thanks again for watching.